Hi, geometry friends. Today we're going to talk about surface area and volumes of spheres. So let's get started with some vocabulary. And I chose to put this figure here because my ability to draw spheres is not very good. So, you know what a sphere is? It's a ball. It's a three-dimensional circular type figure. The cross section of each, if you were like to take a ball and slice it, you know the intersection of the plane and the ball would always be a circle. And so we have a couple of concepts here that we need to talk about. The great circle. So if we're talking about the great circle of a pyramid, it literally is the largest circle that you can have when you are intersecting a plane and the sphere. And notice that it will always pass through the center of the circle. All right. The idea of poles would be the ends of the diameter of a great circle in a sphere. And you know that there's like infinitely many great circles. As long as you're getting a plane that slices through the center, you're going to have that intersection of that sphere, and that plane will be a great circle. So anytime you have the what's the word? Anytime you have the endpoints of a diameter of a sphere, and that's a line that goes from one point in the sphere to another point, but through the center. Anytime you have the diameter of a sphere, those two endpoints will be the poles. And a hemisphere, I think you guys know what that is. Hemisphere would be half of a sphere. So I'm going to color this in very neatly, as you can see. My gifts of coloring are astounding. And so that purple part, minus all the excess, would be the hemisphere, half of a sphere. Just some points of reference for you as we go through some problems. Make sure you know that the any 2 points on a sphere, if you connect those 2 points are going to be considered. The segment that's created is going to be considered a chord. From the center to any point on the sphere will be a radius. The diameter goes through the center just as it does with any circle, and it attaches 2 points of the sphere. And finally, we have a tangent line, which we know goes through exactly 1 point of a sphere. And so you can have a line tangent or a point tangent, a line tangent or another figure tangent, as long as it intersects in exactly 1 point of the sphere. And so we're going to get down to it. This is stuff that you just kind of have to memorize. The surface area of a sphere. And remember, surface area is if I'm painting that thing, I want to know how much area is going to be covered. The surface area of a sphere is going to be 4 pi r squared. All right, let's hold on to that and let's see if we can do a couple problems relating to that idea. So example 1, surface area of a sphere. Find the surface area. So what did I just tell you the area was? Do you remember? Were you paying attention? Did you fall asleep in class? The surface area of a sphere is going to be 4 pi r squared. Let's go back and check, make sure I know. Yay! All right, so that's the surface area of a sphere, and now you guys know it. We're just pulling out our calculator and doing some stuff. So 4 times pi times the radius being 6 squared, right? And so we'll get 36, 4 times 36 times pi. Plug all of that into your calculator. And when I pulled out my calculator, I got 452.4 centimeters squared, right? And remember, we're not doing volume, so we need to make sure that the units will be squared at the end of our calculations. So here in example 2, instead of finding just the surface area of a sphere, which we know to be 4 pi r squared, instead of just finding the surface area of a square, we're finding the surface area of a hemisphere. So initially you'd be like, oh, it's just half. And it would be, but we also have the addition of that base, right? So it's going to be half of the surface area. So the surface area of this hemisphere will be half of the surface area of the sphere, right? So let me think about how we should do that. 1/2 times 4 is going to give us 2. So we've got 2 pi r squared, but we have to remember the area of the circle here, which is pi r squared. So really, I've got 2 pi r squared, another pi r squared. Looks like the surface area of a hemisphere is 3 pi r squared. Now that we have this formula, it's just going to be pretty straightforward for us. So we'll do 3 pi times the radius, which is 2.8 quantity squared, With our calculator, I get 73.9 centimeters squared. So that's my answer there. Let's look at this next one. So for this next problem, we are asked to find the surface area of a sphere if the circumference is of the great circle is 5 pi meters. Oh, well, this is a little bit different, but I think we can handle it. Let's try. So the surface area, remember the surface area of a sphere is equal to 4 pi r squared. Let's hold on to that. What we need to know is the radius. That's going to be really important for us. So let's go back. The circumference of a circle is equal to pi times the diameter, or sometimes we write it as 2 pi r, which is an equivalent form. Since I'm looking for r, I'm going to use this form. The circumference is 5 pi meters. So now I know that 2 pi times the radius would equal to 5 pi meters. If I were to solve for r, I end up dividing both sides by 2 pi, and then I get that the radius is equal to 2.5. Pi's cancel out. Are you guys with me? So now that I have that radius value, this is pretty straightforward again. 4 times pi times 2.5 quantity squared. That leaves us with 78.5 meters squared. And finally, this last example asks us to, or this last part of example 2 asks us to find the surface area of a sphere if the area of this great circle is approximately 130 square inches. So we know what surface area formula is. We're going to now utilize the information about the great circle, the fact that its area is equal to 130 square inches, right? We're going to utilize that in order to find the radius and then get back to the surface area of the sphere. So the area is equal to, watch this now, area is equal to pi r squared, and that's the same as 130. So now we're going to have to solve for r. We'll do this by dividing both sides of the equation by pi and then taking the square root. A calculator would be super helpful in this situation. So I'm going to do 130 over pi, and I'm square rooting that whole thing just to be sure, right? So I'm undoing what's happening to r to reveal that r is approximately 6.43. And now I'm going to take that information and plug it right into this formula and get my answer, hopefully 6.43 quantity squared, which gets me about 520 inches squared. It's supposed to be inches. I just realized something. And if you realize this, you are a rock star mathematician. If they gave us the area of the great circle, which would be pi r squared, all I had to do was multiply it by 4. I'm kind of corny. You see that? Look, pi r squared is this value. I even used it to like go and find r. So all I had to do was hold on to pi r squared and multiply it by 4 rather. So 130 times 4 is 0, 4, 2, 1, 4, 5, 20. Womp womp. I used a whole lot of time, and I'm sorry. I wasted. Oh well. Alrighty. Let's go ahead and look at this example 3. We're going to find the volume of spheres and hemispheres, and so we need a formula for that, which I don't think I gave you. I did not give you a formula. So the formula for the volume, I don't know why I didn't, I had it in the picture, but whatever. The formula for the volume of a sphere, would be the following: 4/3 pi r cubed. So now that we have that formula, sorry for not putting that in another way, but now that we have that formula, it will make sense to be able to find the volume of this hemisphere. The volume of a hemisphere is just going to be half the volume of the sphere. So we then get 4/6 pi r cubed, or 2/3 pi r cubed, okay? And then so now it really is a matter of plugging and chugging, putting values into our equation. So we've got 2/3 pi r cubed, r being 6 to the 3rd power. And I don't know, I've been using the calculator a whole lot. Let me not. So I've got 2/3 times pi times 6 to the 3rd power. What's that? 216. And so I've got 216, We then get 3 goes into 216 times, and nothing happened in there. And then 2 times that gives me 144. So I get 144 pi as the volume. Oh, they did say to the nearest tenth. All right, not too bad. And let's go ahead and use our calculator. So my calculator is telling me I got 452.4 meters cubed for this hemisphere. And it should have been a part B, but I'm going to skip it because it's not here now. All right, so let's go ahead and look at this final example, real world example. The soccer ball globe at the right was constructed for the 2006 World Cup soccer tournament. It takes up this amount of cubic feet, 47,916 pi cubic feet of space. Assume that the globe is a sphere. What is the circumference of the globe? Okay, so let's go ahead. We know that the surface area of not surface area. We know that the volume of a sphere, that's the one I want, is going to be equal to 4/3 pi r cubed. And in this case, this is the volume, 47,916 times pi. And so if I'm going to try to figure out what r is, because I want to know what the circumference of the globe is, so I'm going to look for the circumference, like the circular, you know what I'm saying. If I'm going to look for the circumference of the globe, which to me is the circumference of the great circle, I need to find r. So in order to find r, I'm going to do a little bit of work. I'm going to cancel out the pi's. I'm going to take my 4/3 r cubed is equal to 47,916, and I'm going to multiply both sides by 3/4. You see what we're doing? Those guys cancel out. R cubed is therefore equal to this thing here. And then what I'm going to do with that thing after I deal with it is I'm going to take it to the take the third root of it. So I'm going to take the third root of all of that, and you should have that on your calculator or on Desmos. You'll be able to find a third root, so you can put all this information in. I'm going to do that now. Okay, I have the product of the thing that's underneath the radical, 47,916 times 3/4, but what I need to do is find the third root of that. And there's a couple ways to do it, ways that you may not be familiar with. Hold on, let me go back to Desmos. And so what I'm going to do is I'm going to bring up my keyboard, go to functions, and if you go to miscellaneous, you'll find this guy. All right, and this is the nth root function. Usually we do square root, so it's 2 or understood to be 2, but now we're doing the third root, so I need to just cut this out of here and put this over here. Let me get rid of this part. Sorry for this cumbersome little lesson on using Desmos, but what we get is 33 for the radius. So now r is equal to 33, and what are we talking about? Feet here. We're talking about 33 feet. And so now to find the circumference of that great circle or of the globe, it'll be circumference is equal to 2 pi r, or the circumference is equal to 66 pi. And because 2 times 33 is 66, and I'm just going to leave it like that because they had it in pi form too. All right, so with that in mind, if you guys have a slicker or easier way to do this, let me know. I'm interested. Hopefully it was straightforward. It was using these formulas. Basically, we only had 2 formulas that we used and we riffed off of. We had this one, volume of a sphere is 4/3 pi r cubed. We're talking about volume there. And then we had surface area of a sphere, which was 4 pi r squared. All right, guys, I'm gonna let you go. Please take care. I look forward to hearing from you and talking to you soon. Bye-bye.